Our enzyme here is a hexokinase. I want to be writing the names of enzymes in red. So the hexokinase enzyme transfers a phosphate group from ATP onto glucose at position number 6 to form ADP. So this is the beginning. So hexokinase transfers a phosphate group from ATP. So ATP means adenosine triphosphate. It transfers a phosphate group from adenosine triphosphate onto glucose at position number 6, and the resulting substrate is ADP, that is adenosine diphosphate. So our resulting molecule will be glucose 6-phosphate. So we proceed. That is how we draw glucose 6-phosphate. So I want to write then the formula of these molecules using different colors so that you know what is happening. So this being glucose, that is hydroxyl group. That is the way it is. So that is step number 1. Let's go to step number 2. Step number 2 involves the conversion of glucose 6-phosphate to fructose 6-phosphate. This one is glucose. This one is glucose 6-phosphate. So our next step is the conversion of glucose to glucose, that is glucose 6-phosphate to fructose 6-phosphate. So when you look at the structure of glucose 6-phosphate and fructose 6-phosphate, you realize that the two molecules are isomers. So let me first of all draw fructose 6-phosphate. So for fructose, this is carbon number 1, 2, 3, 4, 5. So this is carbon number 6. So our fructose 6-phosphate will look like this. And so this is the hydroxyl group of fructose 6-phosphate. So this step 2 involves that is isomerization, that is the interconversion of molecules, that is those are isomers. So glucose 6-phosphate and fructose 6-phosphate are isomers. So they are interconverted. So this process is called isomerization, and since it is working on glucose 6-phosphate, it is a hexose phosphate isomerase. Our enzyme is hexose phosphate isomerase. That is the name of our enzyme. And so the two of them are isomers. So our next step will be phosphorylation of fructose 6-phosphate. And this is the third step. Remember, we said that the third step is irreversible. So conversion of fructose 6-phosphate to fructose 1,6-bisphosphate. So phosphofructokinase is the enzyme that works on that, because it's working on our substrate being fructose, and the role of kinase is to transfer phosphate group. So this is it. That is, a phosphate group is transferred from ATP onto ADP onto fructose 6-phosphate to form fructose 1,6-bisphosphate. So that is how it should be. So I'll be using different colors. So this is O, and this is our phosphate group. So this is the way we draw it. So our enzyme is phosphofructokinase. I'll be using red color there. Phosphofructokinase. So the next step involves the conversion of the splitting of fructose 1,6-bisphosphate. So fructose 1,6-bisphosphate is a bilateral molecule. It can be split into two equal halves. So our next step involves the splitting of fructose 1,6-bisphosphate into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. So how do you draw dihydroxyacetone phosphate? Dihydroxyacetone phosphate, it's a 3-carbon molecule. So from the word dihydroxy, that means it has got 2 hydroxyl groups. So it's a dihydroxyacetone, means it is a ketone, so it has a keto group. And it has a phosphate group at carbon number 1. So this is a dihydroxyacetone phosphate, PO3 2 negative. And our second molecule is a glyceraldehyde 3-phosphate. So glyceraldehyde 3-phosphate is also a 3-carbon molecule. It's an aldehyde group. So, and we know that for glycerol, hydrogen and hydroxyl groups alternate. So we are saying glyceraldehyde 3-phosphate. So it has got a phosphate group on carbon number 3. I wanted to indicate phosphate groups with a different color so that you realize the movement of these molecules. So our fructose 1,6-bisphosphate is split into 2 equal molecules. One is dihydroxyacetone phosphate and another one is glyceraldehyde 3-phosphate. So our next step will be conversion of dihydroxyacetone phosphate into another molecule of glyceraldehyde 3-phosphate. So in this case, our pathway branches into 2, and therefore the molecules that will be produced thereafter are 2. So during our calculation, we realized that we should be multiplying by 2 because of this branch at position number 5. So we go to the next step. So what do you think is the name of the enzyme that interconverts dihydroxyacetone phosphate into glyceraldehyde 3-phosphate? Well, the answer is very simple. When you look at glyceraldehyde 3-phosphate and dihydroxyacetone phosphate, you realize that the 2 molecules are isomers to each other. So since they have got 3 carbons, so our enzyme is called triose phosphate isomerase. That is triose phosphate isomerase. So we go to the next step. So this is step number 5. Step number 6. Step number 6 is the conversion of glyceraldehyde 3-phosphate into 1,3-bisphosphoglycerate. So conversion of glyceraldehyde 3-phosphate into 1,3-bisphosphoglycerate. So we are adding another phosphate group onto our glyceraldehyde 3-phosphate so that we have 2 phosphate groups. So these carbons remain. This carbon has got the same atoms, but carbon number 3 and carbon number 2 will be bearing our phosphate groups. So that's how we write it. So it is 1,3-bisphosphoglycerate. So our phosphate group So I proceed. I have said that so at step number 6 it involves 2 things. So glyceraldehyde 3-phosphate dehydrogenase enzyme carries a hydrogen atoms onto NAD plus to form NADH. NADH. So the role of a dehydrogenase enzyme is to carry out redox reaction, that is reduction oxidation reactions. So in this case, glyceraldehyde 3-phosphate dehydrogenase transfers a hydrogen atom from glyceraldehyde 3-phosphate onto NAD plus to form NADH. At the same time, when an inorganic phosphate reacts with glyceraldehyde 3-phosphate, the resulting molecule will be 1,3-bisphosphoglycerate. So our resulting molecule will be like this. At carbon number 1, we have our oxygen atom and the replacement of our hydrogen atom by a phosphate group. So this is how it will be like. So we go to the next step. We go to the step number 7. Step number 7 is the first step of formation of our ATP. And it involves the transfer of one of the phosphate groups from 1,3-bisphosphoglycerate onto ADP to form ATP, and this is the way it should be. So that is 1,3-bisphosphoglycerate to 3-phosphoglycerate. So we shall transfer one of the phosphate group, that is a phosphate group from carbon number 1 onto ADP to form ATP. And our resulting molecule will be like this. Like this. And our hydroxyl group at this particular point will be like that. So this is 3-phosphoglycerate. 3-phosphoglycerate. So the next step is the role of a mutase enzyme. So a mutase enzyme, the role of a mutase enzyme is to transfer a functional group from one position of a molecule onto another position of the same molecule. So in this case, a mutase enzyme transfers a phosphate group from carbon number 3 of 3-phosphoglycerate to carbon number 2. So it will be like this. It will be like this. So this one will be CH2OH. Because this hydrogen will come here and the phosphate group will be transferred. So this one is carried by a mutase. So mutase is a special type of isomerase enzyme that just transfers a phosphate group from one molecule onto another. So this one is 2-phosphoglycerate. 2-phosphoglycerate. So the next step is carried out by enolase enzyme. So the role of enolase enzyme is to carry out a condensation reaction, or we can still call it dehydration reaction, between C3 and C2 of 2-phosphoglycerate, so that we form phosphoenol pyruvate. So it is this group of atoms that are removed from the molecule. So from 2-phosphoglycerate to phosphoenol pyruvate. So our resulting molecule will be like this. Our resulting molecule will be like this. So this is phosphoenol pyruvate. Phosphoenol pyruvate. So and our enzyme is enolase. So this one involves the loss of water molecule to form phosphoenol pyruvate. Our enzyme is enolase. So we go to our last step, the formation of pyruvate. So this step is irreversible. That is the formation of pyruvate. The formation of pyruvate. So this one is facilitated by pyruvate kinase. Pyruvate kinase. So the role of a kinase enzyme, we've said that it is the transfer of a phosphate group from one molecule onto another. So in this case, a kinase enzyme transfers a phosphate group from phosphoenol pyruvate onto ADP to form ATP. So that is what happens, and that becomes our last step of glycolysis. So I want us to go direct to calculations of the molecules that are involved. I want to calculate the molecules. So the first molecule that I would like us to look at is pyruvate, number of pyruvate molecules. Number of pyruvate molecules. So in this case, we can see it is just one pyruvate molecule that is produced. But since our pathway branches from step number 5, we shall be having 2 branches. So we have 2 pyruvates. So pyruvate will be 1 times 2, which will be 2 pyruvate molecules. 2 pyruvate molecules. Let me write 2 pyruvates. So our next molecule will be water molecules. So number of water molecules. So the number of water molecules will be 1 times 2. So those will be 2 water molecules. 2 water molecules. Then our next step will be, which other molecule are we looking at? The NADHs. Number of NADHs. We know that NADH is only produced at step number 6, and it is 1, but since our pathway branches at position number 5, so it will be 1 times 2. So those are 2 NADHs. Those are 2 NADHs. Any other molecule that we are looking at is ATP. Number of ATPs. The number of ATPs produced at step number 7 and step number 10. So it's produced here and here. So it is there are 2, but our pathway takes place twice. So there are 4 ATPs. 4 ATPs. But we want net ATPs produced because we have ATPs consumed. We also have ATPs consumed. ATPs consumed. We have ATP consumed at step number 2 and step number 1 and step number 3. So those are 2. At that point there is no branch. So we want net ATPs. Net ATPs produced is equal to, that is 4 minus 2, which is 2 ATPs. So we can proceed. We can just confirm what we have been looking at. So we have said that at step number 1, glucose is phosphorylated by hexokinase enzyme, and in this process, ATP is consumed. So that means hexokinase transfers a phosphate group from ATP onto glucose at position number 6 to form ADP. Step number 2 is facilitated by hexose phosphate isomerase. Hexose phosphate isomerase comes from the fact that it is working on a hexose sugar, which is glucose, and it is working between the 2 isomers, so it is isomerase, hexose phosphate isomerase. Step number 3, we've said that it is facilitated by phosphofructokinase. The reason why it is working on, it is a phosphofructokinase, it is working on fructose 6-phosphate. So the name phosphofructokinase comes from the fact that it's working on a phosphofructose, and it is transferring a phosphate group from ATP onto fructose. Then the next step, we've said that fructose is sliced by an enzyme known as aldose. That is aldolase. Aldolase enzyme lyses fructose into two 3-carbon molecules. One is dihydroxyacetone phosphate and the other one is glyceraldehyde 3-phosphate. Then the next step is the interconversion of those molecules, that is isomerization. So the enzyme that carries out that one is triose phosphate isomerase that converts dihydroxyacetone phosphate into glyceraldehyde 3-phosphate. The reason why triose phosphate isomerase converts dihydroxyacetone phosphate into glyceraldehyde 3-phosphate is that dihydroxyacetone phosphate does not lie on the dissect pathway. That's why it's converted into glyceraldehyde 3-phosphate. So our next step is step number 6. Step number 6, we said it is facilitated by glyceraldehyde 3-phosphate dehydrogenase. And the role of a dehydrogenase enzyme is to facilitate redox reaction. So in this case, it transfers the hydrogen atom from glyceraldehyde 3-phosphate onto NAD to form NADH. So when an inorganic phosphate reacts with glyceraldehyde 3-phosphate that is hydrogen atomless, we form 1,3-bisphosphoglycerate. That is the molecule. So step number 7 becomes our first step of formation of ATP, energy in form of ATP. So at this particular point, which enzyme is this? That is step number 7. So it is 1,3-bisphosphoglycerate kinase that transfers a phosphate group from 1,3-bisphosphoglycerate onto ADP to form our first molecule of ATP. So we move on to the next step. We have remained with 3-phosphoglycerate. So 3-phosphoglycerate is converted to 2-phosphoglycerate. So an enzyme that carries out such a reaction is amylase. We said that the role of amylase enzyme is to transfer a phosphate group or a functional group from one part of a molecule onto another part. So in this case, amylase enzyme transfers a phosphate group from position number 3 to position number 2 of glyceraldehyde 3-phosphate. So our next step is facilitated by enolase enzyme. So enolase enzyme carries out dehydration or a condensation reaction in which it converts or it brings together hydroxide group and a hydrogen atom to form water molecules. So our resulting molecule will be phosphoenol pyruvate. Then our last step is the energy formation step. which is ATP formation step, we say that phosphoenol pyruvate is converted into pyruvate by pyruvate kinase. Pyruvate kinase is an enzyme that transfers a phosphate group from phosphoenol pyruvate onto ADP to form ATP. And in this process, our resulting molecule is pyruvate. So at this point, we have formed two pyruvate molecules. On calculation, the number of pyruvate molecules will be 2 because our pathway branches at position number 5. Then water molecules will be 2 because of the branch again. That's 1 times 2, we get 2 water molecules. Our next step is number of NADHs will be 1 times 2. ATPs will also be 2 but multiply by 2 so that we get 4 ATPs. But there are ATPs that are consumed at step number 1 and step number 3. So we remove 2, we get 2 ATPs. So thank you very much. If you have any question, don't hesitate to bring it in a comment section of my videos.